Hello, this is Dr. Monica Bimoita and I welcome you all. So this is session number 17 on linear differential equations. So today we are going to see case 4 when capital X is in the form x raised to m. So already we are aware what is general form of linear differential equation. F dy equal to capital X. Now when capital X is in the form x raised to m. So already we know whenever capital X is not 0, it is known as non-homogeneous. Further, the solution is CF plus PI, right? CF already we have found many a times. So PI, it depends on the value of RHS. So today let us see how to find PI whenever RHS is given in the form X raised to m, right? So working rule. Firstly, we have to arrange f of d in ascending powers of d, right? We have to arrange first f of d in ascending powers of d. Arrange f of d in ascending powers of d in ascending powers of d, and then express f of d in the form 1 plus or minus phi d form. F of d in the form 1 plus or minus phi d form. Right? So already we know f dy equal to capital X. Pi is given as nothing but y is given as 1 upon f d of x. So now for this case capital X is x raised to m, and how we are arranging f of d? In ascending powers of d, and then in this form, that is 1 by 1 plus or minus phi of d form of x raised to m. So what is 1 plus or minus phi d form? It can also be written as 1 plus or minus phi d whole inverse of x raised to m. So this is nothing but our Pi. So already we are aware with this formula. What is the meaning of 1 plus x inverse? So it is nothing but 1 by 1 plus x. That expansion is given as ascending powers of x. Whenever plus is there, alternate plus, minus, plus, minus. So this is nothing but 1 minus x plus x squared minus x cubed plus so on. And what about 1 minus x? 1 minus x inverse is nothing but 1 by 1 minus x is nothing but whenever it is minus, all it is plus and ascending powers of x. That is 1 plus x square plus x cube and so on. So this is nothing but our case for, that is x raised to m. So Pi is given in a very easy form. We have to arrange f of d in 1 plus or minus phi d form, so that Pi take the form 1 plus or minus phi d whole inverse of x raised to m. Suppose if it is plus, we have to use this formula. Suppose if it is minus, this. Accordingly, whichever formula we have to apply, that we have to apply. And how we have to expand this? Based on the value of m. Whatever the power is, whatever the value of m is, up to that we have to extend d, right? Suppose m is 2, then we have to expand up to d square only, because d cube onwards it is going to be 0. Suppose m value is 3, then we have to expand up to d power 3 only, because d raised to 4 onwards we are going to get 0, right? So this is all for case 4 x raised to m, right? It is very easy to remember. We have to represent Pi as 1 plus or minus phi d whole inverse of x raised to m, right? So this is our case 4, and already we know case 2, case 3 and case 4. Now let us start numericals so that the concepts will be more clear. Let us take first example. So the first example has been given as solve d cube minus 3d plus 2 of y equal to x. Right? So as soon as we see this question, easily we understand non-homogeneous. Solution is CF plus PI. Further, what form it is? X power m. So m is equal to 1. So you have to expand up to d only. Right? Differentiation of that is 1. D square onwards it is going to be 0. So easily we understand complete solution is CF plus PI. Further, PI is case 4, that is x power m. Right? So let us start solving for this. Complementary function already we know how to solve. Let us consider auxiliary equation. Auxiliary equation is f of d cube minus 3d plus 2 equal to 0. So this happens to be a cubic equation and not in standard algebraic form. So let us go for synthetic division. So putting d value, so if you put d equal to 1, what do you get? 1 minus 3 plus 2 plus 3 minus 3. Yes, we are getting at 0. So synthetic division. Already we know what is meant by synthetic division. You have to do inspection. If I put d equal to 1 or minus 1, what I am going to get as 0. So usually for 1 or minus 1, it comes as 0. Sometimes if it doesn't, then you have to continue the same procedure. 1 minus 1. Check for 2 minus 2 and so on. Right? So let us solve for this. So coefficient of cube is 1. D square is 0. D is minus 3. 2 is constant. So either you can put 0, star, whatever you want. By inspection, d equal to 1. Right? By inspection, d equal to 1. So 1 plus 0, 1. Already we know column wise we have to add. Result we have to multiply and write in next column. 1 plus 0, 1. 1 ones are 1. 0 plus 1, 1. 1 ones are 1. Minus 3 plus 1. Minus 2. Minus 2, 0. So yes, whatever calculation we have done is right. Reduce the equation is, so this is constant d square. Either you can write this fashion or however you want. So minus 2 plus d square. So d square plus d minus 2 equal to 0. Right? So this happens to be a quadratic equation. Multiplication minus 2, addition 1. What are the two factors? So 2 minus 1. 2 into minus 1 is minus 2. 2 minus 1 is 1. So therefore, do not forget this. So we can write as d minus 1. And what is this? D square plus d minus 2 equal to 0. So d minus 1. And for this, what do we get? D minus 1. D plus 2 equal to 0. So d equal to 1, 1 minus 2. Complementary function is, so 1 is repeating twice, minus 2 is a distinct root. C1 plus C2x e raised to x plus C3 e raised to minus 2x. So this is our complementary function. Now let us find pi. So pi equal to, that is y, that is 1 upon f d of x by definition. For this example, f of d is nothing but 1 upon d cube minus 3d plus 2 of x. Right? So already we know whenever x power m represent denominator, that is f of d, as 1 plus or minus 5d. So this is a constant. Let us take 2 common. Firstly, this can be written as what? 2 denominator 2 minus 3d plus d cube. Next, expresses 1 plus or minus 5d. So taking 2 common, what we can write 1. So next is minus something whole by 2. Now what is this? Minus 3d. Yes, this is plus d cube. So we have to write minus d cube, minus minus plus, plus minus minus. This way we have to arrange this. Whatever is the constant, that we have to take common outside, so that we can write in the form 1 plus or minus 5d. And whatever is the sign here, that we are supposed to write here. And whenever it is minus, we have to take care of this part. Right? So once again I repeat, whenever f of d, how you have to represent 1 plus or minus 5d. Firstly, arrange in ascending powers of d. Next, whatever is a constant, take it outside and represent 1. If it is plus, then plus. If it is minus, minus. Whole divided by constant term. Right? So this can be written as 1 by 2, 1 minus 3d minus d cubed whole by 2 of x. So after writing this, just check down once again so that it shouldn't be wrong. So 2, next, okay, this 2, those 2 cancel, minus 3d, minus minus plus d cube. So whatever we have written is right. Now let us continue this. So this is nothing but, so 1 by inverse, 1 by, so this can be written as 1 by 2 as it is. What is this? 1 minus 3d minus d cube whole by 2 inverse of x. So we have to expand up to d raised to 1 only, because x power 1 is there, right? D square onwards it is going to be 0. So this is nothing but 1 by 2 as it is. Firstly, what is this? 1 minus x inverse 1 plus x. Total this 3d minus d cube by 2 I have to write. But d square onwards it is 0. Only d we have to consider. That is the reason I will write only up to here plus dash dash, but do not consider that. Why? Because that you are going to get 0. X power 1, consider only up to d power 1 of x. So let us multiply this 1 by 2 as it is. X into this is x plus 3 by 2 as it is. What is differentiation of x? 1. So this is our answer, 1 by 2x plus 3 by 4. So Pi is this. Complete solution is CF plus Pi. So already we have found CF. Already we have found Pi. So let us substitute that values so that we will get complete solution. Right? So now let us start numerical number 2. So the second question has been asked in the form, solve d cubed y minus 2d plus 4y equal to 3x square minus 5x plus 2. So this is our given question. So here again it is nothing but algebraic. So what form it is? X power m form. So highest is 2. So we have to consider only up to d square only. So complete solution is CF plus Pi. Let us find CF by considering auxiliary equation. Auxiliary equation is d cube minus 2d plus 4 equal to 0. Yes, this happens to be a cubic equation and not in standard algebraic form. So what are the roots? Yes, we have to go to synthetic division. So synthetic division, by inspection when I put 1 or minus 1, I am not getting 0. Right? Now put d equal to 2. 8 minus 4. So minus 8. And this is what? So d equal to 2. 8 minus 2 to the 4 plus 4. Yes, you do not get as 0. D equal to minus 2. Minus 8. Next this is what? Plus 4 plus 4. So d equal to minus 2 is a root. Right? By inspection. So how we have found this? By inspection. Right? D equal to minus 2. So that's what I said. Usually for 1 minus 1 it comes. If it does not come, you have to check for 2 minus 2. If it does not come, you have to check for 3 minus 3 and so on. But usually 1 minus 1 or 2 minus 2, you get as 0. So let us solve by synthetic division. Cubic coefficient is 1, square is 0, d term is minus 2 and this is 4. What did we get? Minus 2. So column wise addition, minus 2, 4. What is this? 2 minus 4. So reduced equation is d square minus 2d plus 2 equal to 0. Right? d square minus 2d plus 2 equal to 0. So you cannot find by factor method. So here a equal to 1, b equal to minus 2, c equal to 2. So d equal to minus b plus or minus b square minus 4ac by 2a, that gives 2 plus or minus 4 minus 8 is under root minus 4, that is 2i by 2 equal to 1 plus or minus I. So I can write therefore d equal to minus 2 comma 1 plus or minus I. Complementary function is y equal to c1 e raised to minus 2x plus e raised to x c2 cos x plus c3 sin x. So this is our complementary function. Now let us find pi. So pi by definition is nothing but y is nothing but 1 upon f d of x. So what is f of d here? 1 upon d cube minus 2d plus 4 of 3x square minus 5x plus 2. So let us solve for this. So pi. So we can take 4, writing ascending 4 minus 2d plus d cube. Taking 4 outside. So this can be written as 1. Next is minus. So you have to write minus itself. Whatever the term, whole divided by 4. So minus 2d. Yes. Plus d cube. So minus d cube. Now it is plus d cube. Of 3x square minus 5x plus 2. So this is nothing but 1 by 4 as it is. What is this? 1 minus x. X is total this. X inverse of 3x square minus 5x plus 2. Right? So let us solve for this. What is 1 minus x? Inverse 1 plus x. This is total x plus x cube and so on. But consider only up to d square only. Why? D cube onwards it is going to be 0. So let us write here. What is 1 minus x expansion? 1 plus x. So x is 2d minus d cube by 4. But no need to consider d cube. Why? It is 0. Consider only up to d square. So I can write just 2d by 4. 1 plus x. In x I will just consider 2d by 4. Plus x square. X square is 2d minus d cube whole by 4 square. That is a minus b whole square. But again consider only up to d square. So what will be this? 2 ones are 2 twos are. So d by 2 square is what? D square by 4. 2ab will give d raised to 3 and b square will give d raised to 6. So no need to consider. Only up to here we have to consider plus dash dash. But we are not considering that. Why? Because that is going to give 0. So as it is 3x square minus 5x plus 2. So now let us find for this. So this is nothing but, so 1 by 2. So 1 by 4 as it is. Let us multiply. 1 into all that will be 3x square minus 5x plus 2 as it is. Next, plus 1 by 2 as it is. Now, differentiation of 3x square is 3 2s are 6x. Minus differentiation of 5x is minus 5. Differentiation of x is 1. 2, 0. So, consider only up to here. Next, plus 1 by 4 as it is. What is d square of 3x square? Differentiation of x square is 2x. Again, differentiation is 2. So, 3 2s are. So, here, differentiation of x square is 2x. Again, differentiation is 2. So, just I have to write 6. 3 into 2, 6. Right? So, now, let us multiply this 1 by 4 as it is. So, as it is, 3x square minus 5x plus 2 plus 3x minus 5 by 2 plus 2 2s are 2 3s are plus 3 by 2. So, this gives, let us write in descending power 3x square as it is. Next, minus 5x plus 3x is minus 2x. Minus 5 by 2 plus 3 by 2 is minus 2 by 2 is minus 1 plus 2 is plus 1. So, this is our PI. CF already we have found. Complete solution is y equal to CF plus PI. Again, we have to write on the CF. Again, substitute the value of PI. Complete solution is y equal to CF plus PI. So, it is going to be very easy. Just we have to see algebraic equation. If whatever is the power up to there, d we have to expand. Let us solve one more last example in this session. So, the question number 3 has been given as solve d cube minus b square minus 6d of y equal to x square plus 1. So again, as soon as we see this question, we understand algebraic, that is x power m. So up to d square only you have to expand. Right? So now let us find CF considering the auxiliary equation. What is auxiliary equation? D cube minus d square minus 6d equal to 0. So d is common everywhere. Taking d outside, d square minus d minus 6 equal to 0. So this happens to be a quadratic. Multiplication minus 6, addition minus 1. Minus 1. What are the factors? Minus 3, 2. Minus 3 2s are 6. Minus 3 plus 2 is minus 1. So, d into d minus 3, d plus 2 equal to 0. d equal to 0 minus 2, 3. Complementary function is y equal to c1 plus c2 e raised to minus 2x plus c3 e raised to 3x. So, this is our CF and PI. PI equal to, by definition, y 1 upon fd of x. For this example it is, so this can also be written as this form. 1 by d square minus d minus 6 of x square plus 1. Yes, f of d, whichever you find easy to solve, that you can take. Instead of this, we can consider this. What is the meaning? 1 by d, later we will integrate, and here same thing, we can express in 1 plus or minus 5d form. Thus this is ascending order, minus 6 minus d plus d square, further taking minus 6 outside. So this can be written as 1 by d as it is, 1 by minus 6 taking outside. So what I am left with? 1. Next, so it is minus or plus something divided by 6. So it is that d. Yes, now it is minus d and minus d square. Now it is plus of x square plus 1. So this is nothing but minus 1 by 6d whole inverse 1 plus d minus d square by 6 inverse of x square plus 1. So this is 1 plus x inverse. So already we know what is 1 plus x inverse, ascending power of x, alternate plus minus. So minus 1 by 6 as it is. I will write, let me write 1 by d as it is. Now what is this? 1 plus x inverse is 1 minus x. So d minus d square by 6, 1 minus x plus x square. So only up to x d square we have to consider. So x square d square by 36 a square. 2ab will give d cube, b square will give d raised to 4. So no need to consider, just you have to write plus dash dash, but no need to consider. What is that? X square plus 1. So let us solve this. Minus 1 by 6, 1 by d. So 1 minus d by 6 plus d square by 6 plus d square by 36 of x square plus 1. So this is nothing but LCM is 36. So into 6. So 70 square by 36 minus 1 by 6 as it is, 1 by d as it is, 1 minus d by 6 plus 7 d square by 36 of x square plus 1. Yes, now let us multiply. So minus 1 by 6 as it is, 1 by d as it is, 1 into x square plus 1, x square plus 1 minus 1 by 6 as it is. What is differentiation of x square plus 1? Differentiation of x square is 2x, 1 is 0 plus 7 by 36. What is 2 times differentiation of x square plus 1? 2x, 2. So this is our answer. Now what is the meaning of 1 by d? It stands for integration. Firstly, let us substitute this, simplify this. So x square, next 2 1s are 2 3s are, minus x by 3, next 2 1s are 2 18s are, right? So what is this? 18, 19, 20, 25 by 18, right? So now minus 1 by 6 as it is, integration of x square, x cube by 3 minus x square by 6 plus 25 by 18x. So this is nothing but our pi. So complete solution is y equal to CF plus pi. So CF has been formed, pi has been formed. CF plus pi. So this is all for today's session. Thank you viewers for your patience. Have a good day. Bye.